Welcome back to the experimental session of elementary electrochemistry course. In the previous few videos, we have shown you a few conductometric, potentiometric titrations and then two conductometric titrations, which were the conductometric titrations were on weak acid and strong base, strong acid and strong base. And now in this third experiment, we are going to combine two types of titrations. One is acid-base titrations, which you have already seen, and a precipitation titration using silver nitrate to determine the concentration of chloride. So, in this particular experiment, I have prepared an unknown solution of a triple mixture, which you can see is a mixture of hydrochloric acid, ammonium chloride and potassium chloride, and the overall strength of this solution in terms of chloride is approximately N by 100. So, we want to use conductometric method to estimate the concentration of individual components, that is HCl, ammonium chloride and KCl. HCl is, as you know, is a strong acid. Ammonium chloride is a salt of strong acid and weak base, and potassium chloride is a salt of strong acid and strong base. So, what we can do in this experiment is that if we take this solution in our beaker and insert a conductivity cell, it will give me the conductance of all the ions combined, and then so when we start a titration of this triple mixture with NaOH, it will first react with HCl, consume H plus and replace it by Na plus ions, and conductance will slowly reduce. We will see a steep decrease in concentration till the H plus ions are consumed. Once H plus ions are completely consumed, then it will start hydrolyzing ammonium chloride and produce HCl, and that HCl will react with the added NaOH. So, what will happen is there will be hydrolysis followed by neutralization of the acid produced. So, we will see a slight difference in the conductance. We will see that the conductance is not changing as fast as it was changing before, but it will reduce slowly. And then when the entire ammonium chloride is consumed, we will see that further addition of NaOH increases the conductance of the solution. So, we will first see a steep decrease in concentration, then a shallow decrease in concentration, and then increase in conductance with addition of NaOH. So, this will give us the estimation of the concentration of HCl, so that you have one line and the second line, and the meeting point will give you the concentration of HCl, and then the second line, when it ends, there will be an increase in conductance, and from there you will get the end point for ammonium chloride. So, this one experiment with NaOH in the burette will give you estimation of HCl and ammonium chloride. Then we have to discard the solution, take a fresh solution of this triple mixture, which is mixture of HCl, ammonium chloride and potassium chloride, and we will then titrate that mixture using a standard silver nitrate solution, which we have prepared again using the very accurate weighing method, using weighing bottle and a 4-digit balance. So, this is a standard N by 10 silver nitrate solution. So, this silver nitrate, when we add to a mixture of chlorides, we will see that a precipitation occurs, silver chloride gets precipitated. We have described this precipitation titration in the theory lecture in the previous week. So, you should now be able to understand what is happening during this titration. So, in this titration, chloride ions will be continuously removed and replaced by nitrate ions, which has about the same conductivities. Therefore, during the neutralization or during the titration of chloride with silver nitrate, as long as there is chloride left, there will not be much change in conductance. It will remain almost the same. But then towards the end of the titration, beyond the equivalence point is reached, when we add more and more silver nitrate, we will see an increase in concentration, we will see an increase in conductance, and that will indicate the end point of this reaction or end point of this titration. So, we will have to plot again the volume of silver nitrate versus conductance in a graph paper, and then in the following lectures I will show you how one can do the calculation and find out the concentrations of these components in this mixture. So, this experiment has two parts. One part is with NaOH titration, the other part is with silver nitrate and titration. Method of titration is the same. You will keep on adding gradually the amount of the solution from burette and reach the will note down the values of conductance continuously and then plot it, right. So, now what we have, you can see in your screen, we have a solution of 0.01 molar HCl, and the conductance that is reading here is 1.441 millisiemens with a cell constant of 1.025. So, we will require the value of cell constant in the calculation. So, to start the experiment, we first need to remove this HCl solution, clean the electrode as before, and then add little amount of water so that the electrode is dipped inside water and the conductance is read in microsiemens, and then we will add 10 ml of this unknown triple mixture and start the titration. So, now I have kept a small amount of water in this beaker and the electrode is dipped. You can read the measurement here, it shows conductivity about 8.06 microsiemens. So, that kind of conductivity is very good for a good quality water. So, now to that I am just going to add this solution of triple mixture, about 10 ml of that using this pipette. So, I am going to pipette out 10 ml of triple mixture from this conical flask and add it to this water present in the beaker, and then start the titration using N by 10 NaOH, standardized N by 10 NaOH. You may be able to see that the conductance of the solution is increasing because now I am adding 3 salts, HCl, ammonium chloride and potassium chloride in a mixture. So, all the ions that are coming here are now conducting, and it contributes in the conductivity of this solution. So, we should make it homogeneous. Right. So, after making it homogeneous, we can see that the conductance value of this triple mixture solution is about 783.3 microsiemens. So, we should note down this value as my burette reading at 0 volume of NaOH. Remember that here the reading is already in microsiemens. So, we write down 782.3 or 782.3 microsiemens. That is my starting point. So here about 1/3 is HCl, 1/3 is ammonium chloride, and then 1/3 is potassium chloride. I have taken 10 ml of the solution. So the end point for HCl should come somewhere close to about 0.3 to 0.4 ml, and for ammonium chloride it should come around 0.6 to 0.7 ml. So we have to be very, very careful while adding this solution of NaOH dropwise. We should not add too much at a time. We always should maintain our gap of 0.04 ml each step and homogenize it and take the reading. So now I have added 0.04 ml of NaOH, and we see that the conductance has reduced to 740.8. So we will continue adding small amounts 0.04 ml each time and take the reading. So at 0.08 ml, the conductance has now further reduced to about 704.1 microsiemens. Now another 0.04 ml is added, so I have reached 0.12, and we see that there is a significant change, 673. While adding, one has to make sure that the drop falls inside the solution and it does not fall outside, because every drop here is very important because it is 10 times more concentrated than the solution that we are analyzing. So if one drop falls outside, the measurement will go wrong. So now we have added another 0.04 ml and reached 0.16. And you see again there is a significant decrease from 673 to 629, 629.3 microsiemens. So now I have added one more portion of 0.04 ml and reached this 590.9. If you see the difference between the initial readings, it was 782, then 740, difference is 40. 740 to 704 is again difference of about 40. Then it is 673, the difference is like 30. Then 629, so 630, that means about 40. So about 30 to 40 microsiemens difference is coming even now with 629, 630 becoming 590. So that gap of conductance between the readings is maintained like about 40 microsiemens, which means that we are still constantly decreasing the conductance because still we are having HCl in solution. Now we have reached 0.24 ml and the conductance is 548.2. So again another about 40 microsiemens decrease in conductance. So with 0.28, we are now close to the what happened? It is not reading. Yeah, so the electrode was above the water level, so it was not reading the correct value. We should wait for it to stabilize and homogenize as well. So then you know that we are close to the neutralization point. You see now it is stabilizing to about 516 microsiemens, 516.2. So what we see is now here when we added 0.04 ml of the solution of NaOH, the reduction in conductance is not in the range of 40 microsiemens, the reduction is in the range of about 30 microsiemens. Now we will add one more block of 0.04 and we will see that probably the conductance will either stay unchanged or will start slowly increasing. So we have now reached a stage where it is 0.32 milliliter of NaOH and the conductance has changed to 483.6. So still it is reducing, but now it is reducing slower. Earlier it was reducing by 40 microsiemens, now it has come in the 30 microsiemens. That means it has deviated from its linearity. So now I have added another 0.4, that is we have reached 3.6 and we see that it has reduced to 457, 457.3. So 460 and 83 is like 26 microsiemens reduction. That means the straight line which was coming is now slowly bending and changing its slope. That indicates that we are very close to the equivalence point for HCl. Now I have added another portion of 0.04 ml of NaOH and homogenizing it again as usual. So we have reached 0.4 ml and we see that the conductance is now reduced to 441.5, which means the difference is just about 16-17 microsiemens, which indicates that probably we have reached the end point, and from here we will see a range where there will be almost no change in conductance for a while, because now we will consume HCl and means it will hydrolyze ammonium chloride, and that HCl will be consumed by NaOH. Let us see how the reading changes. So with 0.44 milliliter, it is staying almost the same, 443. So it is slightly increasing, but I would say it is staying the same within the error limit, experimental error limits, 444.6. So now we should continue this addition till we start seeing that the conductance is increasing. What is happening at this point is that ammonium chloride is getting hydrolyzed and producing ammonium hydroxide and HCl, and we are then neutralizing that HCl using NaOH from the burette. So we see that the reading is not changing, 0.445, that is 445.5 microsiemens. So for last 3 readings, the conductance has not changed at all. I would say it has not changed at all. So we are reaching a region where we will see a parallel line parallel to the x-axis, straight line parallel to x-axis. So this is the region where you will get the concentration of ammonium chloride if we just use this region for our calculation. Again, the value is 444.2. This, I would say, is a very good experimental data where these points are coming at same value even after adding NaOH. So now the reading is 447. This is an indication of slight increase, and with more, I think it may start to show increasing trend, because if ammonium chloride that was present in the solution is almost consumed or is completely consumed, it will start to increase. So when the hydrolysis of ammonium chloride ends and the reaction is over, there is no H plus ion present in the solution, then with addition of more and more amount of NaOH, we will see a constant increase in conductance. So let us continue addition as usual. So every time when you add 0.4 ml, you may end up seeing that the drop has formed at the tip of the burette, but it has not completely formed and fallen in the solution. Then you need to take the drop in solution by touching the edge of the beaker, so that the drop falls in the titration solution. So now I have added another 0.04 ml, so it is now 0.6 ml, and it shows 449, maybe 450. Yeah, maybe 449, 450. So what we are seeing is a slight increasing trend. So probably the end point for ammonium chloride is now passing. We will see the exact end point when we plot. With 0.64 ml, now we see a further increase, 451, maybe 452 it will be, because at this point the conductance value slightly fluctuates, because it is not fully certain yet that the entire ammonium chloride has hydrolyzed. So it may take a while for the conductivity cell to give you the correct or accurate reading of conductance. So I will take this as 452. So there is an increase of 2 microsiemens for every 0.4 ml here. So with 0.68 ml, the reading is 454, maybe it will reach 455 if we wait and let it homogenize and equilibrate, because at this point the neutralization has just happened and the instrument also takes a while to read the conductance very accurately. See, it is slowly increasing, but now it is stabilizing to 455. These points which are very close to the neutralization points, we need them very accurately to draw the actual graph, but these points will not be useful for finding out the end point, as you know that we will have to draw a tangent through all the points which are falling in the straight line. So when we do that, we will see that these points which are slowly changing from constant to an increasing trend, these points will not fall in the straight line. So we will not need these points for accurate endpoint determination, but to show the trend how it changes, we will need these points. Now we have reached 0.72 and the value is probably going to be 458 or maybe even 459 if we allow it to stabilize, equilibrate and stabilize. Okay, so we take this reading as 456.4. And we will continue. So now it is coming out slightly higher, 462. So now we see a change of about 6 plus 4, about 10 microsiemens more. 462.9, 463 is 9 microsiemens. Now I am adding another portion of 0.4 and after that I will add a slightly larger quantities because I then need the points which are distant from the equivalence point. So we have now reached a value of 0.8 ml and it shows about 467, 468 maybe. It will homogenize and give the reading close to 468. Yeah. So it is reaching that value of 468 or maybe plus minus 0.1, and while plotting those last digit will not become so significant. So now I will add 0.1 ml portions and note down the conductance value to get the points which are beyond the equivalence point, because now we are seeing that the values are constantly increasing. Now I have added 0.1 ml. So with 0.1 ml I have reached is 0.9 ml and the conductance value has now increased significantly because I have added 0.1 ml. It should reach a higher value, so it is 485.3. So 485.1, 485 may be the correct value, 485.2 I am taking. So we will add 3 or 4 more fractions of 0.1 ml to get 3 or 4 more points, which will then give me the liberty to draw the straight line through those last 4 or 5 points. So now with 1 ml of NaOH, I have reached a value of conductance 510.6 microsiemens. So we will continue addition in 0.1 ml portions for next another 3 or 4 readings. Since now I am adding a larger quantity, I should wait for a while for the conductivity meter to give me the correct value, so that when we try to plot, these lines should form a nice straight line. So it is now coming like 551.2. 551.2 is my reading after 1.1 ml. Now I have added one more portion of 0.1 ml. So reached 1.2 ml, and we wait for the cell to give us the correct reading, which may take about 5 to 10 seconds. So now it is going to about 600 microsiemens. $599.3. Where should we take a decision whether we should stop or not? If we look at our readings here, the readings for last 5 points are: with 0.8 it is 468, 0.9 it is 485, 1 ml is 510, 1.1 is 551, and 1.2 is 599, that is 600. So in last 2 readings, the increase is like increase is like 40 to 50 microsiemens, whereas before that the increase was about 15 to 20 microsiemens. That means we have not reached a point where we have a constant gap between the consecutive readings over a range of additions, which we were seeing at the beginning, where we were seeing a gap of about 40 microsiemens for each addition of 0.04 ml. So here we need to, I decide that we cannot stop at this point. We have to continue for another maybe 3 or 4 readings, when this gap will become nearly uniform. The gap in the conductance should become nearly uniform. I have reached 1.3 ml, and let's see where the conductance value reaches. It should reach somewhere about 640 if we have reached the uniform increase in conductance point, because with NaOH we should see some kind of uniformity in increase with a certain amount that has been already added. See here that the expected value we are not getting. That means we have not reached a point where with a certain amount of NaOH we see a certain amount of increase in conductance. So we will take 2 or 3 more readings and stop the experiment and then plot and see there may be 1 or 2 points which are not exactly accurate. So I reached point. Now I have reached 1.3 ml and the reading for 1.3 ml is 143, correct. So now we have reached the point where with 0.1 ml addition we are reaching a stage where it is increasing by about 40. So I will add one more portion of 0.1 ml and reach 1.4. And expect to reach the conductance of 680 around that point, 680, 688, something like that. So now we see that we are reaching little more than 688, 695, 697, which is about 40 to 50 millisiemens. 40 to 50 microsiemens increase from the previous value. So these are within the experimental error limits. 695.9 is 696. So this will be our end point for this triple mixture versus NaOH titration. So we have seen a change that was happening between 0.28 and 0.4 ml. So the constant decrease got reduced and the results or the conductance values were flat for a while, and then it started increasing slowly and we continued up to 1.4 ml, which is much beyond the end point of this triple mixture titration. So with this we are finishing the first part of this triple mixture estimation with NaOH. So from the graph we will get the concentrations of HCl and ammonium chloride, but we will not know the concentration of KCl from this experiment. To do the experiment with KCl, we will have to do this titration using a solution of silver nitrate, which I will show after this experiment. So we will continue the experiment in the next video. Thank you.